Hello. Today's lecture will cover the materials from Chapter 17, Time Series Analysis and Forecasting. We will start with some basic concepts. A. Definition. A time series is a set of observations or responses, each one being recorded at a specific time. B. Plotting time series data. The y-axis is the response measured at the corresponding time. The x-axis is a time indicator, say in years, months, minutes, and so on. Here is an example of a time series. Example number 1. The S&P 500 index for year 2009 to year 2013. You can see a pattern, an upward trend from this example. And you see this is a time indicator and the y-axis is the response. C. Time series analysis is used for business forecasting or to predict the future behavior of the estimated model. Say you are a financial analyst and you need to forecast revenues of some companies in order to better evaluate investment opportunities for your clients. D. How do we do forecasting? Through identifying and isolating influences patterns of the time series. Now, let us study the time series patterns. There are a total of 4 time series patterns in our study. Pattern number 1, A, horizontal pattern. A horizontal pattern exists when the data fluctuate around a constant mean. Here is the time series plot for the horizontal pattern. So you see the data fluctuate around this constant mean. The second one on the list is the trend pattern. A trend is an overall or persistent long-term upward or downward pattern of movement. And you can see from this example, we detected an upward trend. And for this example, you have a downward trend. The third one on the list is the seasonal pattern or repeating pattern. It's a fairly regular periodic fluctuations that occur within some period, year after year. And here is the plot for the seasonal pattern, and you have this repeating fluctuations. And in here, 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 and in here. D. Cyclical pattern. A wave-like pattern describing a gradual ups or downward movement that is generally apparent over a year. Here is the cyclical pattern, a wave-like pattern that is not repeat itself. Now, let us study the time series notation. The time series notation is associated with this response, y sub t, t equals to 1, 2, all the way to n. This, at time point 1, the response is y1. At time point 2, the response is y2, etc. And finally, at time point n, the response is yn. Let's look at this example. The following data represent total revenue unit in millions of a car rental agency over the 11-year periods from 2000 to 2010. And here's the data set. So you have 4.0, 5.0, 7.0, 6.0, all the way to 6.5. And then I ask you to plot this given time series. So first, we need to use this notation yt to represent our data. So for 2000, this is y1 equals to 4. For 2001, y2 equals to 5. For 2002, y3 equals to 7. And 2003, y4 equals to 6. And 2004, y5 equals to 8. 2005, y6 equals to 9, etc. And then we plot our data and we can see our pattern of movement associated with our data. Next, we will introduce two techniques for forecasting. Both are involved data smoothing techniques. The first one on the list is this moving average. Moving average is a very useful smoothing technique for forecasting. The moving average method uses the average of the most recent K data value in the time series as the forecasting value for the next period. So here's equation 17.1, and the moving average forecast of order K is given by this equation. F sub t plus 1 is equal to the sum of the most recent K data values over K, which is equal to yt plus yt minus 1 plus all the way to yt minus k plus 1 for the numerator and k for the denominator, where f sub t plus 1 is the value of the time series being computed in time period t plus 1. So in here, we have some concepts associated with the notation we're using. This f is referring to forecast value. T plus 1 is the future value, and this y is the notation we're using for the time series, and t is time. So yt is the current value, and yt minus 1 is the previous value, and then we go down all the way to y sub t minus k plus 1, and k is our order, and k is the number of data points used for averaging. Now, let's see our example. This is the continuation for example number 2. Find the forecasting value for year 2005, 2006, 2007 with k equals to 5. So we use 5 data points for our moving average. Order is k equals to 5. Now, F is the forecasting value. So you have F, so 2005, and this is the future value. And you wanted to take the most recent data points to do our forecasting. So you have F of 2005, that's t plus 1, that's your future value. So your current value will be 2004. So using this equation 17.1, you have yt plus yt minus 1 all the way to y down to y of t minus k plus 1 over k. So you have y, so 2004, because this is the future value, this is the current, and then you go down 1, so it will be y, so 2003 plus y, so 2002, and plus y 2001, and then plus y 2000. So you have 1, 2, 3, 4, 5. You have 5 data points, and then over 5. Now, go back to our data. You can see we have the value start from 2004. So you have 2000, 2001, 2002, 2003, and 2004. So you have 8 plus 6 plus 7 plus 5 plus 4 over 5. So that's how we compute the forecasting value for 2005. So 8 plus 6 plus 7 plus 5 plus 4, which is 6. Now, for year 2016, and this again is a forecasting value, F, and then you add up the data from your time series, and you start with the current value, which is 2005. So you have y 2005 plus y 2004 plus y 2003 and y 2002 and plus y 2001 and over 5. So again, you go back to your data set, and then this time it's for 2006. So you have, for your data point will start with 2005. So you have 9 plus 8 plus 6 plus 7 plus 5 over 5. And that's how you get this 7 as your forecasting value for 2006. And then again, similarly, you use this equation F, so t plus 1 equal to yt plus yt minus 1 all the way down to yt minus k plus 1 over k. You'll be able to find the forecasting value for 2007. And this is 1 over 5 times y to 2006 plus 2005 plus 2004 plus y to 2003 and plus y to 2002. And that ended up to be 5 plus 9 plus 8 plus 6 plus 7 over 5 equals to 7. Now, if I ask you the same question with k equals to 3, then you're going to only use 3 data points to do the calculation. And again, you use this formula and you will be able to solve the problem. Now, we introduce the exponential smoothing technique for forecasting. So this is from equation 17.2. We're going to use the exponential smoothing forecast formula. And this formula is f sub t plus 1 is equal to alpha times yt plus 1 minus alpha times ft. And this is a recursive equation with f1 equals to y1, where f sub t plus 1 is the value of the time series being computed in time period t plus 1. Ft is the value of the time series being computed in time period t, and alpha equals to the so-called weighted coefficient, or is a value that between 0 and 1, and we also call this smoothing coefficient. Now, there are some basic concepts associated with this formula. Again, the notation we are using is F for forecasting, Y for the time series. So in this equation, f sub t plus 1 is the future value for the forecasting. Y is the time series, so y sub t is the current value associated with the time series, and then ft is the current value for the forecasting value. So now again, this is the recursive formula. So you have to set the initial data point to be f1 equals to y1. And then in order to compute f2, you have to have f1 and y1. And in order to compute f3, you have to have y2 and f2, etc. So this is what we call a recursive equation. Now, let's see our example. Example number 2 continues. Find the forecasting value for year 2003 and year 2004 using exponential smoothing technique with alpha equals to 0.4. So for alpha equals to 0.4, then 1 minus alpha is equal to 1 minus 0.4 equals to 0.6. Keep in mind, we need to use this equation 17.2 to solve the problem. So for year 2000, your y1 is equal to 4, and we set f1 equals to y1, which is 4. Now, for year 2001, we have from our data set y2 equals to 5. And based on this equation 17.2, f2 is equal to alpha times y1 plus 1 minus alpha times f1. And now we know y1 is 4, and we also know f1 is 4. So you actually have this equation alpha y1 plus f1 minus alpha f1, which is y1. So you cancel out alpha y1 and this minus alpha times y1. f2 is also f1, and in this case f2 equals to f1 equals to 4. Now for f3, Again, we use this equation, and F3 is equal to alpha times Y2 plus 1 minus alpha times F2. And you will have 0.4, which is alpha, times Y2, which is 5, plus 0.6 times F2, which is 4. So you will have 0.4 times 5 plus 0.6 times 4, which is 4.400. Now for F3, we have 0.400. Okay. You have F4 equals to alpha times Y3 plus 1 minus alpha times F3, which is 0.4 times 7. Y3 is 7 plus 0.6 times 4.4. This is F3. So use your calculator. You will get the value 5.440. Now for F5, and this is 5, so you have alpha times Y4 plus 1 minus alpha times F4. So you will have 0.4 times 6 plus 0.6 times 5.44, which will give you the answer of 5.664. And this is the end of chapter 17.